Welcome to Math 106, Chapter 1.2, where we talk about slopes of curves. Now, previously we talked about a slope of a line and how to find that using 2 points, even graphically. Now we're going to talk a little bit in brief about slope of curves, and throughout our journey here in 106, we'll continue to talk about slopes of curves and how important they are and how we can use different methods to find them. Now, slopes again are not just for straight lines. We still can find them for curves, which is just the tangent line at specific points. So if we want to locate and hone in at a specific point on your particular curve, that is going to be your tangent line. Now, if it's going to relate a little bit more to the 2 points like we did previously, that would be your secant line. That would be a slope between 2 points, which is referring to kind of the average rate of change, because this is no longer a constant rate of change because it's a curve, right? Curves are not straight, right? They're moving all over. So we want to get an average rate at where we're changing. Now, today we're just going to be talking about very in brief tangent lines, and we get to deep dive into those more. Now, looking at this quick graph, can you pick out which of your points has the steepest positive slope? Again, steepest negative slope. Which slopes of all of them are positive, and which slopes, or what would you say the slopes are at C and E? So let's just have you pause the video and just try it there. Now, when we look at your positive slopes, right, this is where your curve or your line is going up. So when you go to look at these, right, notice that if I'm drawing kind of a straight line through these points, right, we want to just try and touch that graph once here, right? Notice that this is a positive facing slope at this particular point. And if I were to do that for all of them, right, notice that B, again, trying to go straight through that line, would also be considered positive. So A and B, coincidentally, both have positive slopes. Now, of A and B, which one has the steepest positive slope, right? It means it's going up faster, right? It's changing faster. So that would be B. Now, which one has the negative slope or steepest negative slope? If we were to do the same thing again, right here at D, and again, maybe at F, right? And F, I'm going to redraw again because I want to try and get, there we go, as best I can, right? So now between D and F, which one is the steepest negative slope, the most negative slope? Well, that would be at D, right? It's going down a lot quicker, a lot faster than F. So D is the steepest one. Now it says, what is the slope at C and E? So let's go ahead and find those two slopes here. What do you believe your slope is here? Now, because these slopes, right, they're horizontal line, what do you know about slopes of horizontal lines? Well, their slopes have to be 0. So for example 2, it says, if we have a set of slope values here, can you appropriately place the slopes accurately on the graph? So they're just telling us, okay, let's say that these are your slopes. Can you match them to now what we have defined about them currently? So let's see if you can pause the video. Now, if you're returning, right, take a look at what we just talked about, C and E. You have a 0 here, so we can go ahead and put those on here as well. So we know that this value here is 0. That value here is 0. What about -8? That's our next number. So we have 2 negatives, a -8 and a -1/2. meaning that D we said was your steepest one. So D is -8. F, therefore, is the other alternative negative, and it's a lot smaller than 8. Well, the 1/2 is, not so much the negative. Now we have 9 and 1. So 9, right, is going up a lot faster. Therefore, it should be here. Same thing with 1 is the smaller of the two, so it's not as steep. So hopefully you guys have the same sort of line here. Now notice that we did not have a point located right here. If we were to draw another slope line, a tangent line, what would you conclude about your slope? Your slope would also be 0 here as well. Now we're going to talk all about why these points here are crucial in helping us down the line. Now our last thing that we're going to talk about is this tangent line. So we are going to be learning how to derive this tangent line and find it, but here we have it graphically. Now, your tangent line is just the slope at one particular point on your graph. And notice that this particular red line is not going through your graph, right? It's touching at that one point and it's getting as close as it can. And it looks like it's touching over here, but it's not. It's only touching at this specific point. So it's touching at the point 1, 1. Now, what is your slope of this red line? Well, your slope here is, let's see, looking between 2 points, we're going to go over 1 and up 2. So up 2 over 1. So your slope here is at 2. Now, can you create an equation of this line? Well, we have a point. We have your slope. Can we go ahead and create an equation? Even better, do we need this particular point, given that we now can visually see this red line? Well, you have your y-intercept here, so we can go ahead and use your y-intercept. If this was not provided, right, we can certainly use your point and your slope here and put it into your equation, just like we learned how to do back in chapter 1.1 previously. So there, your equation of this tangent line at the point 1, 1. So slope, or no, sorry, the equation of your tangent line at the point 1, 1 is y is equal to 2x minus 1. 2 from your slope and your -1 from your y-intercept. Now, you're not always going to be given this graph. That is all what we're doing in chapter 106 is just you no longer have this graph. This graph, however, is y equals x squared. It is just a very basic your parent function of a quadratic.